Welcome, everybody. My name is Bruce Olson. I'm joined by Anahara Mijo. Thanks for taking time out of your schedule today to find out a little bit about EASE 5. You will find a button at the bottom of the webinar screen that will open a panel where you can type questions. Feel free to type your questions when they occur to you. You can also upvote questions that have already been asked to show that you are also interested. We will open up the discussion for those questions after the short presentations we have prepared. Now let's look at what we'll be covering in the next hour or so. There we go. First, I'll do a very brief introduction of EASE 5 and an overview of the software development. Then Anna will take a look at a couple of drawing tools. I'll follow up with some sound system design tools, and then Anna will come back and talk a little bit about tuning a model. This new version of EASE is developed on a new platform with continuous improvements. Since the first release, more than 3 years ago, we have delivered 30 updates. We will continue to add new features, and you can find all about it on our social media channels and our website. And I'll bring back these links at the end of the questionnaire answer period as well. So this new version of EASE is based on a new 64-bit platform with a new set of 3D modeling tools for building rooms. There are many new display and presentation options. We also have many new ways to configure sound systems and tune the acoustic model. Anna and I will introduce those in a moment. And we continue to provide listener seats and audience areas for mapping and analysis. Here are some QR codes to follow us on our social media, register for AFMG News, and get a trial license and so on. Let's see here. So let me jump over to my screen. Let's see here, and that one, and find the correct model. Actually, it's going to Anna, isn't it?
It can. So let me see if I can take over your screen. And again, I welcome all of you. Thank you for joining us, especially for those of you whose bedtime. We appreciate your time here with us. So as Bruce mentioned, one of the things we have is a new geometry building editor. From the number of people we have here today, we probably have a good number of previous EASE 4 users, as well as completely new to EASE users. But I just wanted to show you some of the more recent developments have added the ability to draw curves in faces. So the most obvious and simple one is, of course, just being able to add a circle. But also when we add a polygon, we now have the ability to add an arc as part of that. So for example, I'm going to go ahead and draw what would be a wall. So I'm going up in the Z direction. And then I'm using the letter A to change to an arc, and Y so I can go in that direction specifically. And then once I have added my beginning and end point of the arc, then I'm gonna select my height from the center to be 5, and then I have my arc. And then that's just part of my polygon. I can continue drawing. Now I'm gonna do a straight face and close it. So that's a way to add, for example, what would be if I extrude this, a vaulted volume, a vaulted ceiling. And then I'm going to use some of my tools here. I'm going to duplicate that face and rotate it 90 degrees. I'm going to move it. Actually, let's move it down X. So that's kind of center. And then I'm going to extrude this one as well. So now I have two intersecting volumes. I'm going to go to a new file. I think it's this one. Okay, so I have my intersected volumes. I have now actually intersected these faces using the polygon in face to remove the parts that I didn't need. And now we're going to add another detail using curves as well. So I'm going to do another polygon here. I'm going to do an arc, but I want this one to be, so I'm going to enter A. I want this one to be in the floor. So I'm going to go down the X, and I know that was 20, so that's going to be 10. And I have a semicircle. One of the things is the resolution of these curves is automatic. So the easiest way to remove resolution is just to go around and remove some of those vertices that I don't need. So for example, if I want less resolution, I'll just leave half of the vertices there. In some cases, it might be easier to just draw another circle, picking every other vertex. So there's different ways always to do things in ease. We pick whichever it's more comfortable. And now I'm going to do, using my tools, a duplication of this face and another rotation. I'm going to do that based on the center and rotate these. So now I have those two faces connecting two of my floor vertices. And going back to surfaces, I'm going to draw the side faces for those. Okay. Now, I don't need this face anymore, and I don't need this face anymore. As you notice, these faces are inverted, so I'm going to put them in the correct direction. And once again, I'm going to duplicate and rotate this just 30 degrees. Duplicate that again and rotate. Again, always first my axis, then the beginning and end of rotation. And then once I have that, I can use a different tool, in this case, the mirror, because I'm not at the center of rotation. I just need to move it, and I've created that alcove. So this volume should be now connected. Let's see. This zoom toolbar is always get in the way. Let me just redo this way. And I can see that, oh, maybe this face is inverted. So now I should have a closed volume. So that's one way to draw complex volumes using curves. Again, you can do a vertical arc, you can use circles, you can do a semicircle by drawing the full circle and deleting half the vertices, or just do it using an arc if you know the exact radius of that. I think that's all we wanted to do for curves, Bruce.
Yep. Okay. Let's see here. Let me share my screen. This one. All right. So let me talk about some of our new tools for Acousteer. So we introduced last fall our new real-time engine. It's over here under calculations. When I turn on show mapping, I am able to see the map there. I have a single line array in here, and I've got a balcony and a main coverage. Well, what if this balcony area actually was a little bit lower. So here you can see as I highlight it that I have put in another face that's a little bit lower in the below the balcony, and that's now going to shade that coverage that goes underneath the balcony. So right now I'm looking at the mapping with no delays turned on and with the shadow turned off. If I switch this, we've now got configurations that allow us to switch between different sets of loudspeakers. If I now turn shadowing on without any delay loudspeakers turned on, you can see that at the back of the room underneath the balcony, due to this additional baffle that's in the way, if I look at my side view here, I can see that I am being shaded by this new baffle that's in here, and it's blocking one or two of the boxes of my line array. So this shadowing feature was just added last month, and now makes it really easy to see what's going on. Let's take a look at a different version of this model. Let me jump over to this one here, where now I'm looking at the same thing. Let's go back to calculations. And now I want to decide how do I add some loudspeakers in the back area. So I'm going to do with shadow on and with the delays. And now I can see that I've got 3 loudspeakers that I've added back here. And the first thing that I need to do is I need to adjust their levels a little bit. So I'm going to grab those processing block for the under balcony delays, and I'm going to adjust my level so that I get a more consistent level between the main array and our additional arrays. Added a couple of months ago then was the ability to take a look at the timing of that. This is done considering the precedence effect. Right now we can see that there are no delays on these loudspeakers, and so their delay time is coming in at between 4 and 10 milliseconds. And of course we need to add some additional delay in order to match that up with the arrival time from the main array in the front. So I can also do that in a real-time way here. And I'm just looking to find something that adds, whoops, that's a little bit too far. Something like this, where now as I look here, I can see that I'm at about 40 milliseconds. Here I'm at about 50 milliseconds. So now these loudspeakers, while considering the precedence effect, are going to be aligned at the correct time. Then I can go take a look at each of those using some of our other tools to look at, for instance, the precedence curves in the probe and so on, and see what's going on with that. Okay, the other thing that I wanted to show you is a way of organizing your system for looking at a very complex room. So here we have a showroom that I did quite a while ago, but converted it over into ease, and I've got a couple of different systems in here. I've got some VIP speakers for the boxes in the back. I've got some front fills at the front stage lip area. I've got a house system that is installed in the system, and then I've got a portable system that is brought in when they don't want to use the main system. So here I have configured this so that in this separate 3D view here, I'm going to go modify it so I'm not looking at the faces, and I'm going to switch it to be a different view here. Whoops, pressed the wrong key here on my little Stream Deck. And again, I can look at my calculations, see my mapping here, and have a look at this. So I've got an overview of the project over here. I've got my main 3D view where I can manipulate things. I can see my acoustic parameters here, take a look at what my signal is and so on. Down here, I can see where my materials are. I can also see the distribution graph. I can adjust that distribution graph to look at perhaps 3 dB steps here, see what the average and the standard deviations. Now I'm going to show you the rest of the model, and that is done by jumping over here and sharing my other screen. And there we go. And now I've got all of my stuff over here that are for configuring the sound system. So I can choose a line array here and be able to look at its configuration over here on the right-hand side. I can see the individual properties of each of these processing blocks or the individual loudspeakers. I can then take a look at the DSP and the EQ for that. I've got a variety of different filters that can be added here. I can look at the audience areas table, listener seats table, all of that stuff using both of my screens now to be able to share or to be able to look at all of my models. So as I move through and select things in my other screen, I can then see where they're being highlighted over here on the other screen. So let me go back over on the other screen. I am moving through my loudspeaker table, and you can see each of those things being highlighted. Okay, let's see, do we have some questions? No, we have some raised hands, but yes. So let's deal with some questions. Anna, let's see, I typically have my BIM support export a Revit model into CAD with the unnecessary vertices and objects removed. 2 questions. Is there a way to set my X and Y to 0 after import? It always seems to position way off. Will Ease 5 support Revit imports anytime soon? So directly supporting Revit imports, no, we will always be, or we will for the short term at least, be going through the DWG process, exporting that. When you're using Revit, often Revit projects may be an entire campus of projects, and the origin point sometimes can be a few miles away. I've seen in some of the projects that I've worked on. So what you want to do is in the AutoCAD model, you should set the base point to be where you want to have the origin for X and Y in the Ease model. If you don't have access to AutoCAD to be able to do that, most people who have Revit also have AutoCAD, then in Revit, that's setting the project reference point, and there are ways to do that for that specific export by resetting the project origin to where you want it in the model. Hope that answers your question, Brian. How to adjust SPL levels to more realistic ones. So in the project that I've got here, I can come into my global EQ here, and that has opened up, let me move my thing, and I can adjust my levels, and let's say that I need to turn this down maybe by 20 dB or so, and now my maximum levels are being shown at a more appropriate set of levels. So I can do that with my global gain setting, and that adjusts all of the systems together and maintains all of the relative values that I've got between each of those systems. John Lufick, is there a method to mute solo processing blocks? Send that into support. We're getting more and more questions or requests for that. I agree that it would be nice to be able to mute and solo those blocks. But what you can do is, for instance, a way to do it right now is in the real-time mapping. If I choose over here on my other screen, I'm going to choose my portable mains, and that's got these highlighted here. And when I go into calculations, I can now turn those on or I can turn them off. So we don't have a way to mute or solo, but we do have a way of effectively doing the mute by using the new Acousteer ability. So select a processing block, and then you can switch that processing block on and off and see the contributions automatically that way. And let's see, David. Do I have Ease5 Stream Deck shortcuts available for public distribution? I hope to publish that relatively soon. I've created 7 different screens for my Stream Deck. I'll show it to you here. I've been playing around with it. It's, let's see here. There we go. Let me grab this and bring it over here. So what I've got is I've got a profile for Ease5 that allows me to put in my author information, to do all of the things for loading things. It allows me to do the bringing in the drawings and selecting all of the various locations, so on. So I've gone through and done all of this, and this is what I'm using in order to switch very quickly between all of my views. So I do plan on publishing that. I'm working on optimizing it a little bit still yet, and then I will publish that. Send me an email, David, and I'd be happy to send it to you. Let's see here. Adam Pope, is there support for processor filters and EQ? Not sure what you mean by that. Yes, we can. If I move my share over to my other window here, let's see here. So move this guy out of my way. So as I'm selecting let's say our portable, look at the filter stage for that portable system. There we go. So we can add all of our typical filters here. And as far as loading in processor filters, we don't have that capability right now. You would need to do that using our GLL viewer tool and or Systune, where they've got some links to processors, and you'd be able to bring in those configurations or those filters and then be able to add those here. Send us what it is that you'd like to do, Adam, to support at afmg.eu, and we'll look at adding that to our capabilities. David, is there a change all same function for speakers like in Ease 4? That's something where you can select all of the features or you select all of the loudspeakers. So for instance, if I go into my loudspeaker table and I select all of my front fills, and then I go to my loudspeakers, you can see them selected here. I could now replace that with something else. Let's just throw in ceiling loudspeaker, for instance, and now that's replaced all of those loudspeakers that are there. So you can sort and filter your table, and you can use that to do your selection. How accurate is the RT from acoustic parameter and or RT? I'll let Anna talk about that in a moment. How can I see what the GLL file is associated with a specific speakers. Some manufacturers just name their files version 3, version 4, finding it hard to find what file is actually associated with the speaker in ease. So if I take a look, let's see here, which screen am I sharing? I've forgotten. That one. All right, let me switch it back. Only one problem with Zoom. I guess there's a way in Zoom to have multiple screens, but I haven't figured that out yet. So if I take a look at a specific loudspeaker here, I am not able to see anything more than the description. So it's, I'm not sure that we have a way to do that. You might send that suggestion to support, David, and we should find it a better way to perhaps do that. Let's see here. Do we plan on having some sort of a live link for SketchUp that is real-time updates to the drawing? Not at this point. Again, send your suggestion to support@afmg.eu as to how you would use this, and we'll add it to our list of things to do. Is there a reason that the presentation top bar item disappears? Can it just always be present? It disappears when I am on some other view. The presentation is only for 3D views. So if I choose this 3D view here, I see that the presentation appears. Or if I'm in this other 3D view, note that I've got different settings in the presentation for these different 3D views. So the presentation ribbon is always associated with a 3D view. We are looking at perhaps moving some of these things into the 3D view windows. Suggestions, again, would be absolutely welcomed. Where can I find your email? You can send an email to support@afmg.eu, and I'd be happy to respond. Okay, I think I'll pass it over to Anna.
I think there were also a few questions added to the chat.
Okay. It would be nice if they were in the question and answer. Maybe you can transfer them, or I don't have the chat window available here.
I don't think I can add questions, but let me see if I can get some of these back. So question about SketchUp, we already talked about it. We haven't planned adding the ability to do SKP imports because SketchUp does save to DWG, and that's already possible. So that was one. How can I displace a face? So the command is move instead of displace, as it was named in ease4, but it's basically the same function. Can you do reports automatically with the software? No, we can't. You can save information out of it, like maps and data and tables, but not a full report. It's a hard thing to develop because everyone uses the software to report different things, so it would have to be very highly configurable. But if you have any suggestions that make sense for us to consider, again, feel free to send us an email to the support email address. Let me see if I'm missing anything. Can you
A couple more questions. Andres Does the new shadow map update incorporate the accurate calculation of frequencies below 100 hertz? Yes, it does. So it uses the full frequency range that is available in the main module, which is 25 hertz to 20 kilohertz. And Ellie, are we planning to implement a snapping tool? Not sure what you mean by that. We already can snap to existing vertices. We can also snap to the center point between vertices. And we can use XYZ constraints for those. So I'm not quite sure what you mean by a snapping tool. And then Joe Bridger, is there a way to raise the ceiling, the walls automatically extend with it? Yes, that is the surfaces. If I have an existing surface like I have here, and I want to extrude that, I can. And let's see here. Whoops, what went wrong? Chose something wrong here. Let's try that again. So I can go up from here, and yes, all the walls come along with it. Now, what I need to do then is I need to go in here and get rid of that intermediate face, and then I'm going to be ready to go. And Thomas Ryan, future support for 3D connection. Space Mouse Enterprise, no plans at this point. I've taken a look at that, and to be honest, I chose the Stream Deck instead. The 3D connection mouse, yes, gives us some ability to rotate a little bit easier, but I'm not sure that it's all that useful, but it's certainly something that we'd welcome your input on how that would be useful to you. Adam, again, detailed demonstration of time alignment. I didn't understand what you were doing with alignment of your under balcony fills. Yes, let me go back to that one. Let's see here. So what I've got here is, if I go to my under balcony fills, so if I turn precedence effect off, and now it is simply adjusting the time, and what I'm looking for here is if I switch off my loudspeakers, so I'm going to grab these three here and go back to my calculations. Whoops. Oh, let's see here. Let's grab them this way. And I'm going to switch those off. So right now what I've got is I've only got the main array on, and I'm showing the time. And by the way, I'm showing it in 5-degree increments. I could look at sorry, not degree, millisecond increments. Here I'm looking at 1 millisecond increments, and I can see that as I go back through the room, except for the part that's being blocked off, I can see a gradual change in my delay time, as you would expect coming from my main loudspeaker. When I go back and I switch back on my delay loudspeakers, and take a look at what their delay is with no time added, I end up with delays that are starting over at those delays. What I really want is that prior thing. I want those to be around 40 milliseconds. That was what the level was back there. I'm remembering that from what it was before I switched on the delays. So as I increase the delay, if I go up to that roughly 35 milliseconds or so, I can see that I'm now matching, due to the colors, I'm now matching to somewheres up here. Note that when we're tuning for precedence, that I want to have these, due to the law of the first wavefront, I'd like to have the loudspeaker from the front arriving first. Right now it's arriving at the same time. And so I'm simply adding in 5 to 10 milliseconds in order to end up with a delay here in the area covered by these loudspeakers that is 5 to 10 milliseconds behind the loudspeakers that are there. I hope that that helps a little bit. Happy to answer more questions if you send a request into support. Bert, so if I want to displace specific distance, then I can simply enter that in. So when I go to, let me take this one here and go to my surfaces, and I want to extrude this, go from here, and I'm going to go in the Z direction. And now you can see down at the bottom that it has entered in the cursor into my value. So 25 centimeters, about 1 inch. So if I want to raise that, whoops, let me do it this way, 0. I'm in my strange US units here. Please bear with me. So I want to move that by 25, or you said 25 centimeters, so actually 10 inches. So there we go. Now I've moved it 10 inches.
And with the move command, it works the same way. You can enter the direction and the distance. The difference is that just moving, of course, doesn't create those side faces that have been added in this case. And per Joe Bridges' question before, if you just move it or displace the face, it doesn't drag the ends of those faces that are, in this case, the walls. For previous EAS4 users, that was the case. If you displace a face, it will drag everything that's connected to it. It is not the case in EAS5.
David, can speakers snap to a plane, Shift plus Z? No, they cannot. We had that in some of the earlier versions. Again, that is something that I'm missing too. Add your voice to support at afmg.eu as to how you would use this, where you would use it. Are you talking about ceiling loudspeakers? Are you talking about wall loudspeakers? Or are you talking about other things? That would be good to know. Export to SKP native format would be useful to avoid unnecessary triangulation in DWGs. Is this something we can consider? Certainly. Again, I'll repeat myself, send that request to support. Let's see here. Can we join two audience areas like we do in Surface? No, we cannot. That actually probably would be useful. Right now, what I'm doing is I'm going back to the original surfaces, joining the surfaces there, and then recreating the audience area based on that surface. But that's a great suggestion. Please send it in. Joel, okay. Extrude and delete the original face in a single step. Yep, send that in, Joe. 3D mouse is extremely useful as a shortcut and accessibility device for disabled users with limited hand functionality, more so than the Stream Deck. Okay, great information, Stuart. Thanks for that. Let's see.
We move on to the last demonstration and then go
Yes.
to questions.
Yep. So let me stop my share. And I'm sure Anna will generate more questions.
And this should already be answering one of the questions that we have there regarding the accuracy of RT. As we know, we have a calculated reverberation time here. This is based on the Eyring equation. So it's a statistical RT. It doesn't know the location of the absorption. It doesn't know the location of a source or a receiver. So it's, of course, a limited way of estimating the RT. And then we have the aura calculation, which is the full impulse response created with actual particles in the room. So that's the one that would be more similar to an actual measurement. And it does include scattering as well as absorption. There are, of course, things that are not included. For example, transmission is not included in ease, and diffraction is not included. So some things we can say that it's exactly the same as a measurement, but it's the closest we can get with the simulation. So this is a model of Teatro Colón in Buenos Aires. And as an example, for this room, after I created the model, I have added some general materials from the EASE database. So we have some marble, opening areas, a lot of plaster of two different kinds, stage openings, some leather seating, some upholstered seating, and a stage floor. So those are some generic materials. In general, when I'm modeling an existing room, after I create the model, I want to apply some of those general materials from the library. We don't necessarily have detailed information about what those materials are for or are kind, especially not for an older building like this. Plaster, it's one of the biggest unknowns in this case. And as we can see, there's a lot, in this case, 60% of our surface areas for walls and ceilings are chosen to be that plaster material. So I'm gonna bring in another file here. So in order to tune this room, let me modify this view. So in order to tune this room, I have a measurement done in the room. So that's the row I'm highlighting here. And that's the blue line. So we have, it doesn't have a very large spread for all the measurements that were performed, except at the low frequency. Those are the error bars shown there. And then if I run an aura calculation with those materials that I showed you, it gives me this orange line. So of course, that first pass at assigning materials was not very good. We have some differences between the blue line and the orange line. And then if we look now at the Eyring calculation, that's the green line before. So both of these, the orange line and the green line, are based on those.
No. Anna has intermittent internet. You blanked out for a minute there.
Oh, I'm sorry. Can you hear me well now?
Yep.
Okay. So I was saying that we have the Eyring RT in the bottom and the Aura RT in the orange on top. So the problem with this is that if I try to tune the model using my Eyring, then I'm going to go in the wrong direction. I'm going to probably try to increase my reverberation time to match my measurement, but Aura is telling me that I should lower my reverberation time to match my measurement. So what I did to be able to use the tuning feature in EASE was to calculate a new target Eyring. So the new target Eyring is basically creating a proportional curve using the measurement, the existing Eyring, and the aura that I want to match. So that gives me a new set of values. This set of values, that's the purple line here at the bottom. As you can see, that means that instead of the current iron, I'm moving it even more down. So I'm going to copy those values, and I'm going to go back into ease. And under measure vibration time, I'm going to choose my third octave band, and I'm going to paste those values. So now when I look down here, I have my calculated iron as well as my target values. And at the bottom in my materials in use, I have all my curves. Remember the 60% that was this plaster. So I'm gonna show only that material. So that's as expected, fairly low absorption. And now using my scroll wheel, I can modify. I can also drag them, from here. I usually just find it's easier going down with my wheel. So I can try to get those numbers as close as possible to my goal. So I'm going to go down the curve. I'm going to adjust all of them. And continue here. And then I don't want any number to be actual zero, so I'm going to leave that at 0.01. Of course, that one I can lower it anymore, so I can match it perfectly. So that's a very good match of my goal just by adjusting one material. And I'm going to show the original. So I don't know if you can see well enough. There's a dotted line there. That was my original curve. And then the solid line is where I adjusted. At this point, the question would be, is that fitted line that I created reasonable? So is it reasonable to think that a plaster might absorb that much? So I went from 0.02 to 0.07, 0.08. And I think in this case, for this material, it's still reasonable. So I'm not assuming plaster is 0.4 just to be able to match it. The next step, of course, is to go and run a new aura. So that's this new line. I created a new set of aura responses that averages to the new orange line. So as you can see, this is almost perfectly tuned to my measurements. And of course, my new iron is now even farther away. But that doesn't matter in this case. The one I really want to match is the aura. And in most cases, we need to do this more than once. So as you can see in this case, I accepted that those new coefficients were reasonable, but if they weren't, then I would just tune it a little bit, maybe move to a different material and use those to get a little bit closer and so on, and do this process until I can have a closer line. The goal is not to have a perfect match. Of course, if I run these 3-4 times, that I'm going to get some values that are going to go closer than that. The important thing is to be close enough to be able to trust that my model is predicting the real behavior of the room, or as close as possible. Okay, so I think now we can go back to questions. So I think that addressed the aura calculation versus the acoustic parameter calculation. Okay. There's a question regarding extrusion. If you extrude a ceiling, the extruded walls material are the same as the ceiling material, or of the adjacent walls. Yes, so if we have a polygon here, I'm gonna begin with that, and I'm going to assign a marble floor to that face. And then I extrude that face. Then all of those new faces are going to take on the material of the original face. Okay.
Yeah, so normally what you'd want to do is if you want to have it be the wall material, temporarily change the face of the floor or change the material of the floor to that wall material, then extrude it, then go back and change if you're retaining the floor face, then change it back to its correct material. Or if it was like in the one that I did where it's now an intermediate face that you're deleting anyways, it doesn't really matter.
So for example, I added plaster, then extruded, and then changed the floor to marble. You know, would be kind of a typical scenario for that. Okay. When GLLs are imported from an EASE4 project file open in EASE5, the SPL is rolled off below 100 Hz and above 10K. This does not happen when placed in a GLL in EASE5. Is there a way to adjust the frequency response back to flat broadband other than simply replacing the speaker with a new instance of the same GLL?
Yeah, if you go into the filter for that loudspeaker, you will see that in the conversion from ease, there was brought in a third octave spectrum from 100 hertz to 10 kilohertz. If you delete that, that will get rid of the roll-offs that were there.
Rocky asks, I'm assuming your opening material is just some rough estimation for absorption coefficient value over the energy spectrum. It looked like less absorption at lower frequencies. I'm assuming you're considering a couple of space. We have a couple of different materials. Opening could mean that it's 100% absorbing. So that's an actual open window. Stage opening, of course, assumes that there is a box, stage box there. We also have these opening to sound absorbing space and opening to sound reflecting space. So depending on the condition, and even opening to organ pipes. So all of those make sense in different scenarios, depending on what the room behind is like. How to resolve the difference between aura and iron when just in design and there are no measurements. It's still, the comparison between those two metrics is still the same. One is just calculating a purely statistical parameter, knowing only the amount of absorption, and the other one is actually doing a full impulse response and sending particles and interacting with those phases. So for example, if you have ceiling reflectors and you have absorption above those reflectors, they are not going to have such a strong effect on the RT, but iron will assume that they have exactly the same effect as if you have a wall of absorption right in front of the source. So it doesn't matter if it's during design phase or during remodel, you still want to trust the aura calculation more than the measure RT. Now, the other question is how we tune a model. Of course, there's no tuning for a room that is just under construction. The advantage, though, is that we have more information about those materials to be able to select more accurate options from those materials. So, for example, we know if it's a single gypsum sheet or double gypsum, if it's wood studs or metal studs, if there is fiberglass in the cavities. All of those things we don't necessarily know for an existing room, but we do know for a room that is in the design phase. So we should have more details about those materials. And of course, we don't have a way to check things with the real construction until the room is built, but we trust that the coefficients that we're assigning are from sources that we can trust. And remember, in ease, and just as an example, there are 56 options for gypsum, but we can say, this one comes from Cox and D'Antonio, or this one comes from the noise control book, or from EGAN, or from Meta. So all of these are different references from published sources, and you can choose which ones you think are better to trust or more accurate, or you can have your own set of measurements, or your own lab if you do have those materials. For example, when adding seats to a concert hall, you usually do have specific measurements for that, and you can create that material instead of choosing from the library. How do you interpolate on site, measure vibration time, and the calculated RT? I'm not sure what you mean by that. If you have like octave band instead of third octave and you need to interpolate those values, or I'm
Might
not
mean
sure.
interpret.
Okay, let's let him clarify. You can tell the RT at high frequency, changing the temperature, humidity. Probably the measure model conditions were different. Yes, absolutely. You can, if you have different air conditions, you can change the temperature, you can change the humidity. If you're working in a place with different than standard conditions, or your measurement conditions were unusual, certainly you can start by setting those correctly. Yes. Can you clarify again how you came up with your new I lost it. Where was it? Came up with your new target iron RT. Is this an ease feature on in Excel? So this was just a simple proportional calculation in Excel. So my new target is multiplying my measurement by my iron and dividing by my calculated aura. So it's as simple as that. It's just a proportional calculation of that at all frequencies. And that creates a new statistical curve, but it's not really statistical based on the materials. It's based on the relationship between my goal, my actual goal, and my first calculation. Okay. Does aura tend to calculate higher than measure most of the time? It seems like when I have compared rooms after completion, that my aura was higher most of the time. I think it depends, to be honest. Like I said, there are some things that even aura is not able to replicate from the real room. So it depends on how much those things have an impact. For example, for absorption, we know that if we use kind of a checker pattern of absorbers on the walls, the diffraction, the edge diffraction is going to add absorption that ease is not aware of. So we can make some assumptions regarding those things if we know the details. But I wouldn't say that we can assume it's always going to be higher. If I find auras lower than in is 5 than is 4, is that imagination, or is the process lower with the same settings? So the algorithms for calculating aura have not changed. So it shouldn't be longer. Now, if you are using audience areas instead of listener seats, there is still a translation process of those audience areas to be subdivided into smaller sections when we do mapping. So that could add some time because of those reasons. But for oral response, I don't imagine that there is any difference. Do you have a different answer, Bruce?
No, I think you're right that it is probably related to the audience areas if you're looking at mapping. And that's something where until we've got Aura moved over into the main module, it is best practice to still draw audience areas with four vertices rather than the allowed multiple vertices that we have in Ease 5.
So for an outdoor area, we should always build a virtual box around with 100% absorption. In Ease 4, we have had the option of open room. So in Ease 5, you can still create an open room. You are able to map. So just keep in mind that measuring RT in an open room, it's not really something reasonable, but you can certainly leave the open room and do the calculations. Now, building a box around it or just closing, for example, a stadium, putting just a lid on it or things like that are different strategies that had worked for people. I don't think we have a specific recommendation for that. Again, it depends on the conditions. But just be aware that creating an artificial RT measurement on an open room, it's really not going to be, it's going to be a big assumption. It's not going to be something close to reality.
Yeah, and the Aura calculations don't require an open room. The E standard calculations do require a closed room. So, in general, if you've got an outdoor area, you should be calculating with Aura to give you the best answers.
Okay. Um, we are coming on the hour. Did I miss any questions? What is the easiest way to re-angle the slope of a ceiling or introduce one? For instance, displacing one end of the ceiling. So there was a question regarding editing single verdicts on an existing face in Ease 5. Ease 5 does not allow you to break coplanarity, so that can't be done. We have discussed that idea. It's not, as of now, is not being implemented yet. And we can always hear of suggestions and your experience. There's different ways we could add a way of modifying the vertices and then applying those changes to make sure that coplanarity was not broken at those points. I guess there is no easy answer at this time. If you just need to change the slope, you could rotate, of course, a face, but that doesn't mean that it's going to have the right length. So that doesn't always work. Sometimes, if it's a square, just redrawing might be easier, or deleting one vertex and moving it and then re-adding that vertex. I think that's just a strategy for what you can do faster in the drawing. Do you tend to use particle versus energy in Aura for most rooms? Um,
It depends
so
upon whether you're looking at time or energy.
yes, it depends on what you're trying to predict. So the energy loss method is better for time measures, and the particle loss method is better for energy measures. But at the end, I usually start with lower resolution, but once I need values to actually design with, I go to the higher resolution, and at that point, both methods should be pretty comparable. Okay.
Although,
Um,
what do you mean by PAGA system calculation?
about that. You mean just public address systems? So in EASE-5, you can certainly calculate intelligibility and coverage for PA systems, for public address or alarm systems. However, you can't add multiple rooms in the same file as you do with EASE-EVAC. You need to do one room at a time. Or you can do multiple rooms as long as they're connected. It's a single air, and they're all connected. It's a single envelope. Are there any IA features being developed for future versions? I think at this point, that's certainly at some point in the horizon, but no, I can't say that that we have already a feature in mind that we're working on. Suggestions are welcome. Any other questions that we missed from the chat? There's a question about when will STI be included in Acousteer. So as you saw, we now have 2 different metrics, and that's the first step towards increasing that. So now we have 2 metrics, now we have added shadowing, and that's just the beginning. Eventually, all of the metrics are going to be possible to do in Acousteer in real time. But of course, that's going to take some time to get to that point.
Yeah, so we don't have a schedule for it. It is certainly on planning, but it is it does require some other steps to be completed before we're able to add STI. So that's really all I can say at this point.
Okay.
All right, thank you, everybody.
Thank you for
Ellie has
joining
one
us.
more question.
Oh, when we have 2 adjacent rooms with walls, still we see simulation going through both rooms when this is going to change. So there is no transmission in EASE. So that's why we say you shouldn't do more than 1 room at a time. You can do couple volumes. So if those rooms are connected with an opening, you can do that. But the energy that is being transmitted through that partition is not being considered, only the one that's traveling through the opening. So again, those are assumptions that might be relevant in a specific case. Okay, this webinar was recorded. It will be posted to our YouTube channel when our marketing team has time to process it, and you can watch it anytime. I'm happy that we had so many people, and please keep sending us your questions and suggestions to the support email address. Bruce, do you want to post those QR codes again, just briefly before we close?
Yes, let me put that up here. Let's see here. Whoops. Went to the wrong page. There we go. And I need to share my screen, and we'll leave that up for a little bit. Let's see here. Where is share? There we go. All right. Thank you, everybody.
Thank you.